Hello, sir. My name is pscaa2. I am from CSM A section, and now I am going to present this CA2 assignment which you allocated the program for me. Now we are going to discuss about the topic which is allocated for me. The topic is about example 5 means the problem. 1,000 students at college level were graded according to their IQ level and economic conditions of their parents. Economic conditions means poor or rich. Based on that economic condition, we are going to them group. They are going to be grouped in graded according to their IQ level, means high, low. High IQ members are grouped and low IQ members are grouped. Here we can see in the table economic condition, poor, rich, poor, rich. We will consider them as metrics for economic condition is poor, rich, high, low, total. 240, 160, 400. 460, 140, 600 means the poor students in poor economic condition students, the high IQ level students are 240 students and the low IQ students of the poor economic condition students are 160. Both are mixed, means total is 400. And after economic condition rich of their parents, rich parents, instead 460 IQ level children and 140 IQ low level children. It's total 600. The total students we read in the we read in the question that there's 1,000 students. So here we can see that the total is 1,000. The high IQ level students are total is 700 and low IQ level students total is 300. Test that IQ level of students is independent of the economic condition of their parents at 5% level of significance. Significance word is most important. I will tell that about in the next slide. Now we are discussing about the solution of our topic. Means I explained the question in the previous slide, and now we are going to discuss about the solution. Solution. Here we want to test that IQ level of students is independent of the economic conditions of the parent. So our claim is IQ level and economic condition are independent, and its complement is IQ level and economic condition are not independent. So here in the question they are saying that they both are the independent, but its complement means the question is it's not independent. So we can have to claim that the null hypothesis and alternative hypothesis. First step. At the step one, we will believe that there are two steps, two hypotheses. First one is the null hypothesis. There is no association between economic condition and IQ level. Next one is alternative hypothesis. There is no association between there is an association between the economic level and economic condition and the IQ level. So it is the first step. We will believe that here we can see that the H naught is believed as null hypothesis, H1 is derived as the alternative hypothesis. IQ level and economic condition are independent, IQ level and economic condition are not independent. Here we are interesting to test the independence of two characteristics IQ and economic condition. So we go for the square test of independence. For testing the null hypothesis, the test statistics is x square equal to summation I equal to 1 to r, summation j equal to 1 to c, Oij minus Eij whole square by Eij minus x square r minus 1 c minus 1 under h naught. Now under h naught the expected frequency can be obtained as. Now we can see the solving means we will substitute those values in this formula and we will write the expected frequencies in the table and we can see in the next slide. Now we are going to see the half problem from the in the next slide. Eij equal to expected frequency of the ith row and jth column. Now we are going to find out the expected frequencies. Ith column, ith row and jth column. Ri into Cj by n means row total, means the row total into column total by grand total, means the total of the row and column. Sum of ith row and sum of jth column by total sample size. Here we can see that the E11 equal to R1 into C1 by N. E11 means there 400 into 700 by 1000 means here we are checking the poor condition. In the column there is a total 400 and in the row there is total 700 and the total is 1000. So 400 into 700 by 1000 equals to, if we solve it we get the 280. and E12 R1 into C2 by N 400 into 300 by 1000 120 R2 into C1 by N 600 into 700 by 1000 equals to 420 E22 equal to R2 into C2 by N equal to 600 into 300 by 1000 equals to 180. Now we are going to calculation for O minus E whole square by E. We can see that the observed frequencies, these are all, if we find the values, those are the observed frequencies: 240, 160, 460, 140, and expected frequency 280. Expected frequencies, those are 280, 120, 420, 180. If we sum those all, then we get the total is 1000. O minus E. O means observed frequency, E means expected frequency. O minus E, 240 minus 280 equal to minus 40, 160, 120 minus equal to 40, 460 minus 420 equal to 40, 140 minus 180 equal to minus 40. If we do the square of the O minus E whole square equal to 1600, 1600, 1600. We got all those values are equal. O minus E whole square by E means here 1600 by 280, 5.71. 1600 by 120, 13.33. 1600 by 420, 3.81. 1600 by 180, 8.89. Now, after all those sum total, we got the 31.74. Therefore, from above calculations, we have x square equal to summation I equal to 1 to R, summation j equal to 1 to G, C, O, ij minus E, ij whole square by Eij equal to 31.74. This is the value, means chi square formula. After chi square formula, we have to find out the degrees of the freedom. Will be R minus 1, C minus 1, means row minus 1, column minus 1. Rows are 2, columns are 2. 2 minus 1, 2 minus 1 equal to 1. The critical value of x square with 1 degree of freedom at 5% level of significance is 3.84. Since calculated value of test statistics equal to 31.74 is greater than critical value equal to 3.84. We can see that the 1 equals to, we can see in the tabular column, means in the tabular column is the value of the 1 equal to 3.84, means 5% level of significance is 3.84. We can compare that the 3.84 is less than the 31.74. 31.74 is greater than the critical value. Critical value 3.84. So we reject the null hypothesis. We reject the claim at 5% level of significance. Thus, we conclude that the sample provides us sufficient evidence against the claim. So, IQ level of students is not independent of the economic condition of their parents. We proved that the IQ level and economic conditions are not independent; they are independent. So, we can. So here we concluded that the problem is not independent. So, we will move to the next slide. So thank you for listening my presentation, sir. So I hope you listened well. So thank you and Jai Hind.